So yeah, next let's see, next week there's no class, there's no lab. So because of that, and because of some technical difficulties with the finite element assembly assignment, homework 10, which is FDA assembly, and I think homework 12. Let me check on that. No, they're not canceled. They are due 2 weeks from today. So let me pull that up real quick, and I can double check. No, the final's not canceled. Let me double check here. Okay, so yeah, lab 10 and 11 still due this week, but I think we're missing a lab. That's weird. Okay, so we're doing motion this week. Yeah, so Jared sent out an email about it. I don't remember the numbers exactly, but I do know the finite element assembly assignment is due at lab when we get back from Thanksgiving break. There was one other assignment he mentioned, but I don't remember which one it was. So just check your emails for that. Okay, so today we're going to cover motion simulation. This will also be due the week that you guys get back from break. And so this one, we actually don't have a suspension. That's an NX tutorial that they've put up. So we're going to do one of the Catia tutorials, and I will walk you guys through some of the extra functionality that's not listed in the tutorial. And then on top of that, we're also going to do visualization today, so you can make your screenshots look pretty. There's no actual lab for that, but it does help you guys to get better points for your final presentation if you show your final model with some cool visualization. So just some examples of some of the visualization that I've seen in the past that I did with, well, some of the stuff that I done with my group. Let me pull up PowerPoint real quick here. See if I can find it real quick. I don't know if I have it on here or not. Yeah, so here's some of the visualization that my team did for our car. We've got like a tire. Actually, here, let me do the actual slideshow so you can see a little bit better from current slide. There we go. So you notice you can like put logos on, do some cool lighting. There's one of our suspensions.
Is this NX?
This was an NX, but principles are the same.
Do you have to do everything the same color?
No, that's just the way we chose to do it. There's our battery. Battery's yellow.
So it's all based on the material? Like you can color
Well, you can attach colors on anything you want. You can make it a rainbow car if you want. So there's our surface model. We actually had a screenshot with the surface model so that you could look through the glass portion and see the interior of the vehicle. But I don't have that screenshot with me. So
looking out the back wheel well, so you can see.
Yeah, that's the back wheel well right there. And then there's the actual suspension. So there's a lot of cool stuff you can do with visualization. So I'll kind of show you the Catia visualization tool, show you guys like how to apply walls, how to change lighting, things like that. So we'll go ahead and start with the Catia kinematics tutorial first. So for this assignment, we're going to do the in-class assignment. We're just going to walk through a lab together, and I'll kind of show you some extra stuff that you can do. And then the homework is to just do a kinematic motion simulation of one of the assemblies for your car. And then that motion simulation should be captured into a movie, and then you'll email that movie to BYU 471. But you can also take that video clip and put it right into your PowerPoint for your final presentation.
Each one of us has to do separate?
Each one of you guys can do the same assembly.
So we can work.
Yeah, so if you guys want to get together as a team and build like the suspension and the shock tower and one of your wheels, or like the motor with the gearbox and everything, and do that all together as a team, that's fine. Okay, so let's go ahead and get started. We'll hop into Catia. Come on. There we go. Okay, so my resolution on this is awful. Let me change it real quick. Okay, so we'll open up Catia. And let's move this over. Okay, so to get into the, let's see, that's really bad, isn't it? Is there a way you can, there we go. All right, I don't think you guys can really see much going on here, so I'll try my best to accommodate you guys. So if you go up to Start and go down to Digital Mockup, there's a DMU Kinematics option, and that will take you into the kinematics, mode. So go ahead and select that. It's under Start, Digital Mockup, and then under that there's DMU Kinematics. If you guys are interested, there's also a composites review, so if you guys are doing anything with composites, that's a good one to do. But anyway, so there's kinematics, and then if you go up to Help and go to Catia V5 Help, we're going to walk through one of the tutorials that they gave us. So if you click on Home, it should bring up our list of tables. We'll go down to Product Synthesis, and on the second row, the second one in is the DMU Kinematics Simulator. Yep, DMU Kinematics Simulator. All right, so we're going to go ahead and click on Getting Started up here at the top. And then there's Designing a V5 Mechanism. Entering the workbench. And we're going to do a kinematic analysis of a bunch of bars, kind of setting it up to be some similar to like a chain, I guess you could say, or a 4-bar mechanism. So the part is right, if you scroll to number 3, it says select the rods.cat part. If you click on that, it'll let you open it inside of Catia by default. If you're at NTU and it doesn't give you that option, you can go ahead and save it to your desktop, and then you can open it inside of Catia. Okay. All right. So the first thing we're going to do is we're going to set up some constraints to kind of simulate different types of joints. Inside of Catia's help section or help documentation, if you scroll down a little bit, there's under user tasks, there's about joints. So if you click on that, it'll bring up a table, and it will describe all of the different types of joints. So if you guys aren't sure what type of joint to apply, you can say, well, here's a revolute joint, and it allows 1 degree of freedom. In this case, it's a rotation, it's an angle. And so you can only rotate in one direction, like around the Z-axis, Z, Y, or X-axis, and it can't translate or anything else like that. So we'll be using the revolute joint today. We're also going to be using a cylindrical joint. This one allows rotation in one direction, but also allows translation in another direction. Okay? And then if you're curious about any of these other types of joints, there's like a ball joint, which is a spherical. There's a planar, which allows translation in 2 directions and rotation in 1 direction. So you just kind of got to look at the model that you're using to figure out how this thing's supposed to move. And you should be able to easily calculate how many degrees of freedom you'll need to simulate the joint accurately. So those are the types of joints we're going to use. But if you come back up here to the part, we should have it open already. We're going to go ahead and go just step by step through this. So creating a mechanism and revolute joints. So you can follow along here. I've already done this tutorial several times to make sure I understood it. And it's actually fairly easy. So I'm just going to go ahead and kind of hop right on in. So the first thing you'll do is you'll create a new mechanism. To create a new mechanism, all you have to do is just click on the joint that you want. and they'll bring up a dialog box that says mechanism, and you can just click new mechanism and name it whatever you want. So you can call it, yeah, I just clicked on the Revolute joint. Anytime you click on any joint, because that's the first thing you need to do anyway, it will pull up this dialog box and ask if you want to create a new mechanism. So you can have an assembly of mechanisms if you wanted to. You could set up this thing to be a chain, and then you could also have like a gearbox as your second mechanism, and rotate the first mechanism and have rotate the gearbox mechanism and have this chain go around it. So you can have multiple mechanisms in one part. We're just going to do a simple one mechanism, I guess you could call it. I'm just going to call it mechanism 1. And so the first thing you'll need to do in line 1, if you click in the box, is you'll need to define where the Revolute is going to pivot. So if we zoom in a little bit, we're going to go ahead and grab this. Now this is really frustrating, so you guys will kind of have to move your mouse around a little bit. But eventually it'll bring up a line like that. Yep. So that center axis is going to be where it pivots. The second line will be the second joint and where it's going to pivot. And like I said, those are really hard to get sometimes. I find for this particular one, if you hover around this little edge, you can usually pick it up. And then you need to select a plane. So we're going to make it so that this part is going to be on top of this part. And we'll press OK. And now they've got a constraint. So those will now pivot in one direction, or rotate around in one direction, and they have a connected joint.
So you select the faces that are touching?
Yeah, I select the faces that are touching. We'll go ahead and repeat it two more times to basically get this thing set up. So we'll do another Revolute joint. We don't need to create a new mechanism, but we could if we wanted to. And then you go ahead and click on line 1. There's the first one. There's the second one. And then for this one, let's have this face be on top of this face. So there's our second joint. Same mechanism. Yep. So they're all in one mechanism. So the mechanism name should already be there. If you missed that step, just click new mechanism, and it'll allow you to create a name the first time, and then each time it should already have mechanism 1 as the default.
I think you got to switch one of those faces.
Maybe.
Unless you're not bending the ball.
Let's put the last one on top.
No, it should be okay.
Oh, I see.
So let's grab that line and grab that line, and then we'll have this face be on top and this face be on the bottom. There we go. Okay, so you'll define joints for everything. Our last joint, we're going to put a cylindrical joint on, and we're going to put it on this last one. So this will allow translation and rotation. And if I could grab that, there's the first one, there's the second one, boom. There we go. Yeah, so for the last one, I used a cylindrical joint. So this will allow translation and rotation.
Translation in what sense?
In the sense that if I have a mechanism here, I can rotate in one direction and I can translate. So that might not necessarily be the direction that I'm translating it in, but it just allows that degree of freedom.
So why would you want us to?
Well, in that case, it allows me to take this piece and slide it down this face if I wanted to. So like I could create a bar slider. Okay, so once we've defined all of the joints,